Hi, everyone. Thanks so much for joining today's webinar. If this is your first time joining, welcome. And if you've joined us before, welcome back. My name is Alex Kelleher, and I'm a marketing specialist here at IMEC. I'll be your host for today's webinar. IMEC is a team of industry improvement specialists with the goal of igniting manufacturing excellence in Illinois in areas of leadership, strategy, growth, operations, workforce, and technology. Before we get started, just a couple of notes. We're recording today's session. Within a couple of days, you will receive an email notifying you when the recording is available for on-demand viewing, along with additional resources on this topic, including the slide deck. We also invite and encourage you to use the chat window to submit questions as they arise during the presentation. We'll relay those questions on to our presenter, and at the end of the session, we'll open it up to more questions. At the end of the presentation, you'll see a QR code for a brief survey about today's webinar. Your feedback helps us shape future content and ensure we're delivering topics and resources that matter most to Illinois manufacturers. We also encourage you to follow IMEC on LinkedIn to stay up to date on upcoming events, resources, and insights relevant to your organization. With that, I would like to introduce our speakers today, IMEC Technical Specialist Jeremy Smith and Lauren Rennie Vandemark, the Sales and Marketing Manager at Flexline Automation. Please join us first in welcoming Jeremy.
Thanks, Alex. Yeah, thank you all for joining live. For those of you that are watching the recording, thank you for watching the recording. A really brief introduction from my side. I want to thank Lauren and Flexline Automation for volunteering at my request to present today. Lauren and Flexline have I think, a unique approach that makes automation quite accessible. So as we were entering this second in the series of webinars around kind of targeting the casting and forging operations, but also broadly manufacturing in Illinois, she felt like a natural go-to. So I appreciate her being here. She's got really a great presentation for you all, and hopefully there's something useful for everybody in it. And yeah, I'm looking forward to it. Lauren, please take it away.
Thank you very much, Jeremy, and IMEC in general. I really appreciate the opportunity to speak with you guys today. I am truly honored to be here, but I think a lot of you might be asking yourselves kind of the same as I did whenever Jeremy first approached me about this. Why her, right? What gives her the insight to be able to talk to us about automation? So as Alex said, my name is Lauren Rennie Vandemark. I am third generation with Flexline Automation. We are a material handling integrator located in Chester, Illinois. Um, Flexline started in my grandfather's farm shop in 1984. It's the brainchild of my paternal grandparents and my parents, stemming from an encounter between my late grandfather, who was selling industrial filtration equipment at the time, and an engineer at SKF Bearings, who was responsible for launching this revolutionary new conveyor product in the North American market, FlexLink. And you might be thinking, it's a conveyor. How revolutionary can it really be? But the ability to use modular tabletop conveyor to move products in a variety of ways and directions in a really small footprint compared to belt or roller conveying was really quite exceptional. And it's still really cool. But over the years, Flexline has grown from being a FlexLink conveyor only company to being a women owned small business with a full line of material handling solutions, including a variety of conveyors, feeding equipment, robotic solutions, and all of the ancillary equipment that goes around all of those, really for product handling during production and end of line processes. So I have grown up around automation, right? It's actually kind of funny. My mom likes to tease me that I am the only 40-year-old with 40 years of work experience in the industry. And she's right. I've been answering phones here since I could toddle. But having grown up in the industry, I've been exposed to a lot of different solutions. And honestly, it kind of takes a lot for me to get excited about automation, right? For example, the picture that you're seeing there, that was my first time ever seeing a robotic machine tending application in person. It was a family trip, i.e., customer calls. If you've ever been in a small business, you know the struggle is real. So we took that trip in 1991. And when I got back from break, we had to do the grade school thing where you have to share what cool experience you had, right? And did I tell them about the robot? Absolutely not. There was a snowbank that was as tall as I was, and that was what I was really excited and thought was the coolest thing from that trip. So I didn't really realize at that point just how cool this industry was. But I think that all of that and all of that experience and exposure is what gives me a really unique perspective on how automation works and how automation works in a variety of facilities. And I'm really excited to get to share that too, with you today. So that brings up the question, what is automation, right? So I was at Modex about a month ago, and I was doing interviews for the Automation Ladies podcast. And one of my favorite questions that I got to ask everybody was, what do you think of whenever you think of automation? Because the word automation means something different to each and every one of us. You can kind of tell by the graphic that I found when I searched for automation that it's kind of confusing. Like it's a really confusing construct, right? Like is it IoT or is it the Internet of Things or is it SCADA? Is it a robot? Is it lots of screens doing things? Is it just the color blue? Like, what is automation? And the truth is that automation is a really general term that encompasses all of those things and then some, right? So one fun thing was while I was at Modex, I was talking to someone who also said that they were in automated material handling solutions, which is generally what I say that I do. And by that, he meant that he was making hand carts, which is not what I do. So even whenever you get really niche about what you're saying in automation, it can be confusing because I think at its heart, automation is anything that makes a human's life easier. And that can be technology, it can be software, it can be machinery, and it can encompass pretty much any task or process out there. Um, but whenever I say that I work in automation, I mean material handling automation, integration, not hand cart manufacturing. And by that, I mostly mean the physical equipment and not the control side of things, because there are companies who say automation and they mean the control side of things. So I just kind of wanted to make that clear. That's all they do, and that's great, but that's not the lens that I'm coming from. So I'm meaning conveyors, robots, AGVs and AMRs, wrappers, labelers, all of the ancillary equipment that goes around moving product from point A to point B. That's where most of my experience lies, and that's really where we're going to explore today. So I've got this slide in here because what you see is the progression of automated solutions for a single task, in this case, screwdriving. And I've got this in here because I think it makes a really good point. There's still a time and a place to use the screwdriver. Automation is not one size fits all, and it isn't the best solution for every single application. You shouldn't ever automate just for the sake of automating. I've seen more robots sitting covered in dust, like in a semi-trailer in the back 40 version of the parking lot, because somebody bought it without having a plan in place for how they were going to use it. You know, robots can't just be dropped in wherever you've got a human working, even with all of the amazing advancements that we're having in the industry. And there are some really cool things out there. But automation only makes sense if it's actually improving your process, you're increasing your profits, or improving your efficiency, right? So, with that, how do you know what to automate? Well, the good news, or maybe the bad news, is that you can automate a lot of different processes now, and it's getting easier and easier than ever before to automate just about everything. But all of those options can be kind of paralyzing. So, where should you start? And I think that the place that everybody should start looking at their automation journey is by asking their people, what job does everybody hate? Right? That's the first thing you should look at automating. And there's a saying, automate the dull, dirty, and dangerous jobs. And that's absolutely true. But I think the heart of what that saying is getting at is that you need to always start with your people. Then you can explore your process. Are you having a lot of reworks in a certain location or procedure? That's a great secondary place to start looking. And then only after you have explored your people and your process should you look at your product. And that's going to ensure that you're going to be getting the most out of the automation that you're installing. So, again, what job do you have a really hard time keeping filled? I hate to tell you, but that's only going to get harder to keep that job filled. I attend the Association for Advancing Automation, or A3 forum, every year, and there's always a variety of speakers, and they're always referencing how many open jobs we're going to have in the United States by 2030. But for the purposes of this slide, I am referencing a fact check report by CargoSun um, that was fact checked in 2025, like the fall of 2025. So in June of last year, there were 415,000 manufacturing job openings. And in the manufacturing sector, we are expecting to need an additional 3.8 million workers by 2033. So even if you're lucky enough to have all of your positions filled right now, you're going to most likely start feeling a crunch because 26% of our workforce is over the age of 25, or sorry, not 25, 55. And that retiree gap is going to only increase as we're going forward here. So fabricated metals alone is expected to be down 1.5 million workers. And automotive is looking to be down 1.4 million, and machinery manufacturing is going to be down 1.3 million workers. But don't worry, because you're not alone. The Bureau of Labor Statistics says that the demand for robotics engineers is expected to grow by 9% by 2030. So it's going to be a hard time hiring for me too. We're all in this together, right? So, with all of that in mind, I think it's really obvious that finding employees is what I consider to be the biggest reason to automate. But there are additional reasons to automate, right? Like helping your employees. That's a really big thing and a big consideration. And with what I do, everyone is always afraid that automation is going to come in and take their jobs away. But two things here. One, it's been shown time and time again that by automating, companies actually need more employees to keep up in all of the other areas because it causes the companies to be able to grow in so many ways. And two, especially if you follow and start with the people, you're automating the jobs that people don't want to be doing anyway. Start with your people. I can't say that enough times, but don't ever think of automation as just taking away jobs. You're replacing those jobs with better jobs. So there's many reasons to automate, even if you can find employees. And I think the second biggest reason to automate is you need to make a safer environment, right? You can't overlook this. Machines can take over hazardous tasks. They can reduce workplace injuries in dangerous environments. And you might think, aren't robots just as dangerous? And the truth is that yes, a robot can be just as dangerous, or maybe not just as dangerous, but a robot can be dangerous if a risk assessment isn't performed properly, right? But I looked into this, and a NIH article analyzing OSHA severe injury reports found that despite the headlines, there were only 77 robot-related accidents from 2015 to 2022 in the US. So I think that the headlines are kind of skewing perception a bit, and the majority of our 4.8 million robotic installations that we have here are improving worker safety. And they're doing those jobs like the press tending robots shown in the upper right-hand corner here, that are really dangerous for people. And in my experience, the dangerous jobs are often the ones that you're going to have the hardest time filling anyway. Um, and that doesn't just mean the overtly dangerous jobs like that press tending application. I'm also kind of meaning the kind of repetitive, strenuous jobs that lead to long-term injury and production mistakes. So a robot or a dedicated machine is not going to get tired. They're not going to be a quarter inch off because their shoulder hurts that day. One nice thing about automation is it's really consistent, right? And this video from KUKA shows the kind of repetitive, precise, accurate work that robots are just fantastic at doing. And this is the kind of work that a human worker can do incredibly well, or less well, depending on where they are that day. Fatigue changes, force and dwell time. There can be uneven removal. They can make gouges, or there could be leftover burrs that can cause rework and scrap. And I've also heard that sometimes operators will replace abrasives a little bit early because it makes their job just a little bit easier on them. So that drives up the cost of your consumables and is something that you need to take into consideration. So automating tasks like these ensures that every casting is meeting the same standards every time, and it's protecting the worker from potential hazards. So you may also need to consider the mental benefits of shifting those repetitive chores like this grinding, sanding, material removal, and palletizing application to a robot, because that is improving the employee's life, right? We spend a whole lot of time worrying about whether zoo animals have an engaging enclosure. But when was the last time you looked around your office or your production space and considered the environment? By automating, you are freeing up those workers for strategic, creative tasks that are more rewarding. And automation is creating an opportunity for your operators to be able to upskill and advance and remain within your corporation by advancing. And that's going to contribute to your long-term growth. So I would be remiss if I didn't also include this reason in here because you hear it a lot. But productivity isn't the driver, in my opinion. Productivity is a natural result of well-implemented automation. Productivity is what happens when you put your people first. Because even if an individual action that is being automated is slower, the gains of the system being the same and operating the same 24/7 really can't be overstated. They are going to allow that cell to produce the same hour over hour. And if you need to scale, then you're going to be able to accurately predict what a duplicated system is going to be able to do. Machines and software offer long-term labor planning with fixed operating and overhead expenses that is a big boon, especially if you're trying to compete in an international market. With this, you can actually also gather a whole lot of information and data from the system that might be a little bit hard to get from your employees, and that can really help you inform your decisions. So all of those reasons are fantastic, right? Like it makes perfect sense to automate. So what's keeping you from automating? Oh boy. Over the course of my career, I have seen a whole lot of barriers to automating. And a big one that I don't see a whole lot of people address is the mental component. Again, I can't tell you how many people I talk to and have worked with that we start a line optimization walkthrough with the words like, I don't want automation, or I don't want to have to get a robot. And automation and robotics, they're not dirty words. We've got to stop treating them that way. We've got to address that mental block that a lot of us have against automation, especially in smaller manufacturing facilities where we really need automation in order to be able to grow. Aside from that soapbox, though, there are some traditionally big barriers to automating. It can be really expensive. Hardware and software costs can add up quickly. But you've got to remember that the value of an automated solution is more than just the sum of the component costs, right? Uh, Traditional ROI calculations don't always take everything into account because the production team trying to justify the cost of the operation isn't necessarily the same group of people that knows the true loaded rate of an employee, or they may not be taking into consideration the cost of a time loss incident or how much it costs to train and recruit new employees. Especially in casting and forging, there can also be unpredictable imperfections. You don't always get the same burr, the same place with exactly the same thickness. So it's been historically hard to automate tasks, especially around like material removal, welding, and quality control. Then you've got to take into account the environment. Can a product even withstand your environment? There's a lot of hostile factors going against automation in a casting and forging environment. You guys have a really hot and abrasive climate there. There's lots of particulate that like works down into joints and abrades camera lenses, and it can be difficult, and so you address all of that, right? Who on your team is going to make it work? Um, Implementation and maintenance look a lot different with automated solutions than they do for even traditional automation or dedicated machines, And a bonus barrier that I think is often overlooked, and I don't think it can be overstated, is that if you don't know a solution exists, you can't implement it. Um, it's my job to travel to trade shows and watch webinars and read all of this literature and information about the latest and greatest technologies and how they're going to revolutionize manufacturing. And I don't have time to parse it all. Like, how can you be expected to? It's one of my passion projects, really, to get this information out there, and especially to target my fellow small and mid-size rural manufacturers because it's daunting. It's easier to just power through and do it the old-fashioned way than trying to figure out how to do it differently. I know it. I struggle with it too. But one thing that I have learned over the last 40 years is that there are resources out there. You don't have to do anything alone, let alone automate your facility. So let's break down those barriers. Let's address this first. In addition to grants that IMEC could help you discover, or the ETIP funds that might be able to help you cover the costs of training, or Section 179 tax credits, one of the coolest things that I'm seeing as a trend in our industry is the rise of ROS, or robots as a service. And you can see a handful of the platforms that are doing this here, and this is by no means inclusive. But what ROS is a way to take a traditionally CapEx expenditure and instead make it a subscription service. You pay for the robot hourly instead of upfront, and the company that you're working with is responsible for maintenance and programming on that robot arm. So currently there are limited applications being supported. usually in warehousing and the end of line space. But I do foresee this model gaining a whole lot more and more traction as companies like Path bring it from palletizing to applications like welding. And I fully anticipate that you're going to see companies who begin to offer ROS solutions for sanding and grinding in the near future, if they're not already. And what advancement in automation is making that possible? Physical AI. So, physical AI bridges the gap between digital intelligence and the physical world using sensors, cameras, microphones, LiDAR, radar, all of that to get data from the physical world and gather it and be able to recognize objects, understand context, determine a goal, act in the physical world, and then use the data gathered from that in order to better understand the outcomes and be able to use that information the next time that you do a process. So this is allowing a huge change from the kind of procedural step-by-step programming that you usually see done in robotic automation. And it's supporting a lot of these implementations because even with the slightly more adaptable kind of if-then statement programming, there's really limited flexibility, and the robot can only handle so much variation without needing a program change. But this is allowing these companies to be able to remotely support this. You know, VLA or vision language adaptive models are changing the way that robots are being programmed. They're allowing programming to improve and learn from data and experience, which in turn is allowing for more variation in product presentation and in the products themselves. So I'm seeing this technology being used a lot in bin picking applications right now. A few years ago, it was really expensive and time consuming to get all of the possible variations of a part loaded into a model so that you could do a bin picking system. But improved AI cameras are able to create 3D images now with just a scan, and it's getting easier and easier and cheaper to train models on parts. And I think the coolest thing about this technology is that with like a 4K resolution, you can perform precise inspection on tiny details and complex surfaces. And I was lucky enough to see a live demo of this software and hardware combination that you're seeing playing as a video right now by MechMind. And I got to see it in person render in real time. And solutions like this combination of hardware and software are addressing applications with varied lighting and varied parts so that we can automate tasks that even 10 years ago would have been too hard to justify the expense of, like quality control. And instead, now we can actually flag issues that might even pass an operator inspection. It's just really cool to see the advancement of that. And the combination of AI and these improvements in cameras are allowing for more variation in the parts. As I said, you know, variation in applications and in the environment that these parts are being presented in. And I like this video because it's kind of showing a culmination about what we're talking about. And let me play that for you here.
Hi, my name is Matt Klein. I'm the director of robotics at Path. One of the major pain points with traditional automation is getting a new part set up for your robotic cell. In traditional welding, an engineer would take a weld drawing, hand it to one of the welders on their floor, and they would go and weld the part. With traditional robotics, that engineer would hand it instead to a robot programmer, which would then have to go and program every single motion for that part for every single seam. But with the Path system, that same engineer would use our job builder software to upload a CAD model, annotate the part, and then our AI handles all of the motion planning and welder commands without any programming whatsoever. Now let's take a quick look at Job Builder and what it looks like to use our software. Job Builder makes it really easy to annotate your parts, whether they're small or very large parts like this, with hundreds, if not thousands, of seams. In order to annotate a part, you just zoom into the seam, select the seam, choose the joint type and weld size, and click Save. Once you've annotated all of the seams, our system takes over and generates all of the motions and weld parameters for the entire part. After selecting a seam, you can choose to use single pass or multi-pass. Our AI creates a set of default weld parameters, but you can also adjust things such as contact to work distance, work and travel angle, as well as weave settings. This takes something that typically takes days, weeks, or even months to program and condenses it down into less than an hour. With the path cell, we use our vision system to identify any variation between the CAD and reality. And we're able to make those small corrections to get sub-millimeter level accuracy on every single part. So we're able to make adjustments to the fill plan, the voltage, the wire feed speed, the travel angle, and work angle, all on the fly. All right, let's go weld.
So Path is currently only using Yaskawa robots for their applications because they wanted to make sure that they had an industrial robot solution that would really hold up in a rough environment. And speaking of environment, there have been more and more innovations made in making robots, especially more robust to be able to handle more and more varied environments. Like, yes, you can still get a sleeve for your arm to help protect its joints from heat and air particulate. But as we're seeing robots being asked to perform in environments away from traditional manufacturing assembly lines, we're also seeing advancements in joint technology. Because something as simple as replacing a traditional O-ring that will fail due to thermal degradation with something like a Z-shaped seal from ISPR or IPSR makes a big difference in durability and longevity in that arm. Universal Robots came out with an IP65 rated collaborative robot, and Stovely has an IP67 version that actually is pressurized to prevent particulate from being able to get into the joints. And even KUKA has an entire line of foundry robots that are designed using a special heat resistant steel. I see a lot of new solutions on the horizon for addressing things like non-traditional environments. There are a lot of really cool technologies and advancements happening in agricultural robotics, for example, that I think we're going to see reflected in industrial robotics with regards to durability and the spaces that those robots are expected to perform in. Little things like different designs in AMR drive systems that are proven in the rough terrain of a field so that they can go over cracked and crooked floors in an older manufacturing facility, I think are really going to make a big difference in automating those facilities. And so we've kind of touched on cost and production variation and environment. So let's talk about labor. You can't eat. Even if you address all of the other roadblocks, unless you've got people who can support your automation, you can't automate effectively, right? So I touched on vision language adaptive models earlier with regards to programming, but I want to take a minute to explore that a little bit more because VLAs are not just making it easier for robots to adapt to different products and different processes, but they're also making it easier and easier for robots to be programmed. There are a lot of third-party platforms for the majority of robot manufacturers out there that are taking minimal human input and essentially allowing the robots to program themselves by writing their own code and doing their own path planning. And this is a huge step forward. I do foresee a future, a very near future, where humans are able to explain a task to a robot using our native language, and the robot's going to be able to write its own code in order to complete that task. In the interim, I do have to give a shout out to Universal Robots and their software platform, though. So you might know Universal Robots as a pioneer in the cobot space because they have force sensors and other safety measures built directly into the robot arm itself. But one of the things that I think make the UR so collaborative is actually their software platform. Um, Actually, while I'm thinking about it, you might have heard the air quotes or seen the air quotes if you're watching the video whenever I said cobot, because according to the latest Robotic Industries Association or RIA safety standards, there's no such thing as a collaborative robot anymore, only a collaborative application, which has technically been true this whole time. If you put a flamethrower on the end of your cobot, it's not going to matter how many safety sensors are in the arm itself. Like, it is not safe for someone to stand next to that robot while it's doing something. Um, so those safety standards just kind of clarified that a little bit. But anyway, the controller for a UR comes with a teach pendant that has a really intuitive drag and drop programming style that is really the bar in easy user interfaces, in my opinion. Whenever you pair that with their free online academy, the combination means you can take someone who's never programmed a robot before and have them writing programs in record time. We've been at career fairs and had high school students, learn how to program a, a robot in under 10 minutes. And I had an extern earlier this year that completed the online academy in the morning, and he was programming pick and place robotic applications for me to use as marketing collateral like later on that afternoon. So I guess what I'm really trying to say here is that robotic programming is not as hard as it once was. You don't necessarily have to know Python to be able to program a robot anymore, and that's getting easier and easier and more accessible all the time. It's not out of line to be able to take someone who is manually doing a task like welding at your facility now and teach them how to program the robot and then be able to train it and kind of mentor that robot like they would a younger employee. A lot of the larger robot manufacturers are offering free online programming now, and they're moving to a low code, no code type of programming. Kind of, well, honestly, I think all of them are discussing it at least on some level. And as far as your employees go, I think being able to call themselves a robotic team lead or programmer or whatever title you come up with internally is really going to appeal to new hires. And those new hires are going to be able to pick up these kind of tablet interfaces really intuitively. Um, so we're also seeing a lot of strides in platforms making automating and designing automation easier. One of the few things that I personally cannot do is draw in SolidWorks. But platforms like Vention, which you're seeing right now, are making it so you don't necessarily have to have CAD or SolidWorks skills in order to create layouts and solutions for automated cells, which is really making it a lot easier to design and implement automation. And if you do know how to use CAD or SolidWorks, like it's allowing you to do those things so much faster than you would if you were doing them all just in SolidWorks and going out to make MasterCar and downloading all of the models for each and every assembly that you were trying to make. So there are resources out there to get your team up to speed, but what if you don't have a team, right? What if you need expert insight? Coincidentally, this video from Vention starts out with a box erecting application, and we here at FlexLine have our own patented box erecting platform, the Box EZ. And I can tell you from firsthand experience that There is a lot more to making a box than what you would think. They are so finicky, and that is not the kind of application that I would ever recommend someone just decide to do with no outside assistance whatsoever. So, what do you do if you need some help automating, right? Well, a big way around that is to work with a company like mine that's going to specialize in helping manufacturers automate. Companies, manufacturers come to integrators when they want single source responsibility for a project. You can call me or another integrator and describe your product and your process, and we'll do the heavy lifting for you. You tell us Allen Bradley or Siemens, and we'll basically figure out everything else that the system needs to run effectively, set it all up, run it all off, and then come install it for you. And how do we do that? So an integrator is a company that doesn't necessarily manufacture something. Instead, we take components from various other manufacturers and we bring them together to create a complete solution. So I think the biggest benefit of working with an integrator as opposed to working direct with a manufacturer is our ability to source the right component for your application rather than trying to make every job fit into our portfolio of products. And while we at FlexLine specialize in conveyance and material handling and end-of-line applications, there are integrators out there that specialize in controls or in sanding, welding, material removal applications, or welding applications. And we are more than happy to direct you to a company that does what you need. And I think you're going to see that more and more with integrators because especially most of us in the small and mid-size space would really rather get you a solid solution than try to reinvent the wheel, so if you have any of those applications, feel free to reach out to me. I'm more than happy to connect you with somebody. Um, as I was saying, there are integrators of all sizes and all specialties out there at all sorts of different price points. So if you don't have the experience or the staff on hand, leveraging an integrator to do it for you is a fantastic way to approach automation. There are also a lot of really good resources and companies out there that do the same thing for safety and risk assessments. In the US, the onus of safety is on the end user rather than on the manufacturer. But if no one at your facility is able to perform a good risk assessment, there are resources. If you've got a safety person on site, I would recommend having them look into the robot safety course that A3 has. It's online. I believe you can even apply for ETIP money to cover the cost of the training. I took it myself. It's only 2 days. I can't recommend it. Well, I can't recommend it enough. If you're wanting just some free training resources, Universal Robots has free e-learning on robot safety training on their website, which is a great place to start. And I haven't worked with Vista Safety personally, but they are a B2B partner with the Illinois Manufacturing Association, which I thought might make them a really good resource worth exploring, because I figured that many of you listening might be a member of the IMA as well as being interested in IMEC webinars. So, lastly, the last one that I've got on here, I really, really enjoy working with Loitza on risk assessments. They're a provider of sensors and other safety components. So someone on their team not only can provide a real risk assessment, but someone else can come in and actually provide a suggested solution to address any of the issues that come up. And I really like that because then you don't necessarily have to figure everything else out yourself. You can really lean on somebody who does that professionally. So they are just a fantastic partner and resource, in my opinion. But if you take nothing away from this webinar but this, I will consider it a success. You know, you don't have to make your automation journey alone. There are so many cool things that make automation more and more accessible than ever. And there are more and more people and companies here to help you automate effectively and safely, no matter where you are in the process. So, thank you again so much for your time today. I know that we just did a very high level look at all of this. But thank you so much, IMEC, for asking me to speak to you. And if anybody has any additional questions or if anybody would like to keep the conversation going, please feel free to connect with me on LinkedIn. You can scan the QR or just look me up there, send me a message. I'm happy to connect or give me a call at Flexline. Happy to chat with you. And yeah, with that, I'll turn it back over to you, Alex.
Thanks, Lauren, for sharing your expertise with us today. And thank you to everybody for attending and engaging throughout the session. At this time, we'll open up the chat for more questions, but we'll start by asking Lauren a couple that came in during the presentation. Um, do you use AI on systems at Flexline?
Yes. So a lot of the cameras that we use have AI already integrated in, so that they can do things like quality control on barcode scanning, for example, and just make sure that all of the print is there or make sure that all of the parts are present before something is being case packed. And that's already being built into a lot of the cameras and a lot of the technology that we use.
You mentioned RAS as a potential for end-of-line palletizing and welding. We have an application in mind that likely needs custom end-of-arm tooling. Is robotics as a service possible for the arm and CapEx for the tooling?
Oh, so that would depend entirely on the provider that you wanted to work with or that you found to work with. The only reason that I think that they might be hesitant to do kind of that portion broken out is that since they are owning the programming and everything, they're going to need to kind of own that end of arm tool as far as being able to make sure that it's going to work reliably with the rest of the cell. Because any downtime is basically going to be money that they are not making on that solution. So I know, um, oh gosh, is it Rapid Robotics? I think Rapid Robotics does custom 3D printing of end of arm tooling for palletizing applications, just as a standard part of their solution. Um, so that would be one that I would recommend reaching out to for that. But I think it's going to be very dependent on which provider you go with.
Um, okay, who helps figure out ROI on a project?
So if you don't have a team, or even if you do have a team internally that is figuring that out, I would recommend if you're working with an integrator to have them help you with that. There are also lots of resources available online. I know A3 has a ROI calculation tool, but I think you might have to be an A3 member in order to have access to it. So long story short is though that like either you can do that or the integrator, whoever you're working with, will have resources available to help you.
And then what kind of entry-level jobs will it create?
So it's going to create a lot of different entry level jobs because it's going to kind of raise the bar away from those kind of crappy jobs that no one really wants to do anyway, right? Like that's what automation is doing. Instead of replacing those jobs, it's just lifting everybody up. So entry level jobs are going to be more like minding the robots. A lot of the technical schools are starting to have programs around maintenance and programming of robotic solutions. And I think that a lot of those are probably going to be good pathways towards kind of robotic tender or robotic programmer or whatever title that winds up being used to define the person who is responsible for resetting after, there is a stop for some reason, whether that's like running out of product or resetting in between different changeovers and things like that.
Okay, that looks like that's all we've got for now, but like Lauren said, she's got her contact information, so if you have any more questions, feel free to reach out. Before we close out our time together, just a few reminders. Please use the QR code on this slide to provide feedback about today's webinar. And then within the next day or so, you'll receive an email with today's recording, slides, and any additional resources. To see other upcoming webinars that we're hosting or to register for the next session in this automation series, please be sure to visit the IMEC events page. I also encourage you to follow us on LinkedIn, where you can stay up to date on all upcoming webinars and in-person events. So on behalf of IMEC, thank you for joining us today and have a great day.
Thanks, guys.